We're in section 11.6 in Algebra 1, talking about inverse variation. Okay, so 11.6, inverse variation. So when we talk about inverse variation, we're talking about things a little differently. We had direct variation and inverse variation. So under this inverse variation, we're given an overall formula where k equals x times y. Or more importantly, y equals k over x. Once again, where x is our input, y is our output, and k is our constant. Okay, so k is telling us how we're varying. So when we start thinking about inverse variation, we start thinking about things that as x gets really large and starts growing, y is getting smaller, okay? Or as x is getting smaller, then we could look at that y could be getting smaller with it as it's approaching negatively. But for the most part, we start considering the simple fact that inverse variation has different style. One's going to be large, one's going to be small, and they're going to kind of reflect about with each of those. So considering what we know so far, we know direct variation. So we have direct variation and inverse variation. Okay. Under direct variation, we had y equals kx, or k equals y divided by x. So this was our constant of variation. Direct variation, 0 had to go to 0. So x and y, we had to have that coordinate point of 0, 0. So if we start considering what's happening here, what's ever happening on our graph, we talk about having a positive k, so k is greater than 0, or we could have a negative k. Once again, when k is less than 0, we talk about that 0 goes to 0, but we have a negative in here going with it. Under inverse variation, okay, inverse variation, once again coming just right up here, y equals k over x. If you notice, x is in the denominator. Okay, so x cannot equal 0. We also notice that x is not going to be 0, y is not going to be 0. Now do realize this is going to change in the next section as we start moving things around and complicating our equation. But for as it is right now, we should be fairly basic with knowing that 0 and 0 aren't going to happen on these. So if we start thinking about this overall on our graph, okay, we start recognizing that on our x, y graph, we have some asymptotes, okay? So x cannot be 0. So we have this dotted line where x cannot be. And we also see that y cannot equal 0. So x cannot equal 0, y cannot equal 0. So our overall xy axis really is asymptotes. Unlike here where we're crossing at that origin, we can't have any points that are on this axis in here. So we got to reflect from on here. So now we have a couple different scenarios. If k is greater than 0, we see that we get these points coming like this. And then we also get some points coming like this. Now, once again, this is just an overall curve to this graph of what's going on with it. Finding a different color here. Well, let's just go black. If k is less than 0, we are going to be over in here. And then over here. So we start noticing we get some, as x is growing positively or it's growing negatively, we're seeing that those y values are getting closer and closer to 0, but they never will equal 0. And as we do a couple examples, you'll see how this works a little bit better. So let's start off by taking a look at number 10. So if we look at number 10 in our book, we're looking at y equals 1 when x equals negative 2. So it's asking us in here, it says suppose y varies inversely with x. We want to write the equation for this. So do realize we need to figure out what k equals. So remember, k equals x times y. So we're going to take our x, our negative 2, we're going to take our y, 1. We're going to multiply those together, and we see that k equals negative 2. Now do realize we are not done with this. One of our better ways to write our equation is in the form y equals k, which was negative 2, over x. And this would be our equation that we could write for this problem as we're looking at it. Looking at number 18. Okay, so number 18, they give us xy equals 12. Okay, as we're considering this problem, so as we're considering this, it tells us to graph this problem. Here we're talking k, so k is greater than 12. So you can come right back up here to this equation and realize, hey, we should have some problem looking like these orange lines right here because our number in reference is greater than 0. So we want to keep that in the back of our minds, but let's go a little bit more in depth. So let's just do a basic xy table. As we look at an xy table here, let's just choose a couple values. I'm going to go negative 12, negative 1, 0, 1, and 12. Okay, so if I plug this in here, well, I'm going to first solve this for y. So if I have x times y and I want to solve this for y, I'm going to divide over by y, so I get 12 divided by x. So now I can easily substitute in and find my y value. So 12 divided by a negative 12 is a negative 1. 12 divided by negative 1 is 12. 12 divided by 0, what? Undefined. Okay, we can't have that. If I divide by 1, I get 12. If I divide by 12, I get 1. So if we start looking at our points on our graph here, once again we have our xy plane. We see that x cannot be that 0 right here. And we also see that, hey, no matter what we're doing, we are not getting y equaling this. So once again, we have that horizontal, with this horizontal asymptote, we see this vertical asymptote with everything. If we come here and we go negative 12, so if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, negative 1. So we see we have a point right here, and then negative 1, negative 12. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We see we got this point right here. Whoa, how do I connect those? What's going on here? Well, if we think about this, maybe we need to pick in another point. So if I put in a negative 3 here, okay, so a negative 3 would give me a negative 4. If I put in a negative 4, I see a negative 3. So we're seeing that we're getting this curve. Now, something to be thinking about. If I picked a number in between 0 and negative 1, took 12 divided by, let's say, negative 1/2. So 12 divided by negative 1/2. So if I take something and I divide it by a fraction, that means I'm really multiplying by the reciprocal. So you see at negative 1/2, let's take this all the way up, negative 24. That's way off on the paper here, and I better not write on my desk here. So we see that we just keep going down like this. If we come to our other side, we see that, hey, this is kind of mirroring over here. And we're seeing a reflection about the origin. Okay? So once again, because we have this origin reflection, it really aids us in figuring out what's going on with this overall graph. Now do realize I am not going to be very particular with the curves on here. I'm more worried that you're in the right areas of it. So If you're not doing the table substitution, don't worry about that. It's more in the guidance of being able to tell what's happening here. If we go to number 24 now. Okay, so on number 24 here, they talk about y equals -1 over x. Okay, so they gave us to us in this format right here. So if I start looking at this graph once again, we see that, well, x cannot be 0. So we see that we have this undefined line going right here, and we also have this undefined line going right here. Okay, so because we have this procedure that's happening here of x can't be 0, y can't be 0, now we start looking at the fact that, well, what's k? So if we think about this, any x value I put into here that's negative, like -1. So -1 divided by -1 is a positive 1. So we're seeing that whatever going on in this problem, because this value is negative, we're going to be graphing up here when x is negative, and when x is positive, a -1 divided by a positive number is going to be a negative number. So we're going to see that we're going to be also down here. So the main points of this is really to go from here and here as we're looking at the problems. Number 26. 26 talks about do the data in each table represent direct variation or inverse variation? Write the equation in which it represents. So they give us this table. So they give us an XY table. They say 4 goes to 15, 6 goes to 10, 10 goes to 6. And they ask us, is this direct variation or inverse variation? Okay, so remember, direct variation and inverse variation had very distinct values or formulas for k. In direct variation, k equals y divided by x. In inverse variation, k equals x times y. So what we look at here is we look at the fact that, well, what's going on? So if I start with my direct variation, I take my y and divide by x. I take my y and divide by x. I take my y and divide by x. Okay, so I have 3 different answers here. Okay, so I got these 3 answers right here. 15/4, 10/6, 6/10. Do they equal each other? Okay, so equal each other. Okay, and if we look at this, this is greater than 1, this is less than 1, so this is obviously no. If we come over here and we look at x times y, so if I go 4 times 15, I go 6 times 10, I go 10 times 6. Well, 4 times 15 is 60. 6 times 10 is 60. 10 times 6 is 60. Okay, so we see that, yes, okay, we have inverse variation. Okay, and once again, I just use IV as capital letters here, or direct variation, inverse variation. So it's not direct variation. Yes, it is inverse variation for this problem. Looking at another example, 32. Number 32 says that suppose y varies inversely with x. We want to find the constant of variation k and then write the equation. So they say x equals 1/2, y equals 5. Okay? So what we want to do is, first thing, we want to find k. So remember, k equals x times y. So we're going to take 1/2, so k is going to equal 1/2 times 5. 1/2 times 5 is 5/2. It is 2.5, 2.5, but we can leave it as this fraction in here. So then we come and we write an equation where y equals k, which is 5/2, over x. Now do realize that this is also 2.5. I would suggest, like always, we always want to leave our improper fractions for our values. One more example in here, looking at number 34. Okay, so on number 34, we're given these coordinate points. And they basically ask us to, each pair of points is a graph on an inverse variation. We want to find this missing value. So we're given that this is inverse variation. Whatever going on here, it's on the same graph of inverse variation. So if that's the case, we know right here that k would have to equal 3 times 5, which is 15. So we know that y equals 15 over x. So this is our equation, okay? So this is the equation for that inverse variation. Okay, we have our equation now. Now it asks us to solve for y. Well, if we're given x is 1, we got to find y. We're going to substitute that 1 into our equation now, and we see that we have 15 over 1, so y equals 15. Okay, and this is just solving a problem. Once again, do not forget to write our equation as it sits here, and then solve. So don't just start looking at problems and going to find the answers. We're really going through the problems, because once again, as we keep growing in here, these problems are going to get more complicated as we move things around or have multiple variations.